In this video, we are going to look at some application problems dealing with marginal analysis. So in this first problem, we are looking at the cost of producing X units of a commodity, and it's given by the function C of X equals 100 plus 19X minus 0.5X squared. And they are asking us to find the marginal cost function. And so anytime you're dealing with a marginal cost function, as you can see here, that means you're going to be taking the derivative of that function. So when I look at my function, the derivative of any constant is 0, plus when I derive the 19x, remember you're going to take the power, pull it to the front and multiply it, so 19 times 1 is 19. And then you're going to decrease the original power by 1, and when you do that, that becomes x to the 0. But remember, x to the 0 is just like saying times 1, so we typically don't even show that. And then minus, and then we have a power of 2 that's going to come to the front, multiplied by 0.5, so half of 2 would leave me with a 1. And then when you decrease that power by 1, you're left with x to the first. So my final simplified answer would simply be just a 19 minus x. Okay, so on this second equation, again, they're giving us a cost function. This time it's 880 plus 0.6 times x, and they're asking me to determine the average cost. Now, anytime you average something, you're going to just simply take what it costs and you're going to divide by the number of items. So if I take this cost function and I divide it by my number of items, which is x, if you split the fractions apart, you've got the 880 divided by x plus, notice that the x's would cancel on this next one, so you would just be left with the 0.6. So that would be your average cost function. Okay, so now we have a supply company that charges for 90-gallon tanks, and they use the demand function, P of X equals to 20.2 minus 2.2 times X. And they want to know what is your revenue function. So anytime you are trying to write a revenue function, you're going to take the price of whatever it is that you are dealing with times your quantity, and they're letting x be the quantity in this case. So they gave us this particular function for price, so if we take that, 20.2 minus 2.2 times x, and we multiply by our quantity of x, when I distribute that x, I'm going to end up with 20.2 times x minus 2.2 times x squared. Okay, in this particular problem, we're dealing with the weekly cost of producing X jackets. It's given by the function C of X equals 1600 plus 35X plus 0.35X squared. Now they're wanting to know what is the marginal average cost. So you got two things going on here. We're going to first have to figure out what the average cost is. So that's where you're going to take the cost divided by x. So 1600 plus 35x plus 0.35x squared divided by x. And I'm going to go ahead and break all of those apart. So this becomes the average cost. And break my fractions apart. So you get 1600 over x plus just a simple 35. And then plus you get a 0.35 times x. And so then, because they said the marginal average cost, that means we take the derivative of that. Now, before I take the derivative, I'm going to rewrite the 1600 over x as 1600 x to the negative first, just because it makes it easier to take the derivative. And then the rest of this is okay. Okay, so now when I get ready to take the derivative of this average cost function, when I pull the power to the front and multiply, that becomes a negative 1600. And then when I decrease that power by 1, it becomes x to the negative 2. Remember, the derivative of any constant is just 0. So we can say plus 0. And then plus, when I pull what's understood to be a power of 1 down to the front and multiply. And then when I decrease the power by 1, you're left with x to the 0, which just is like saying times 1. So on my final answer, notice they do go ahead and with that x to the negative 2 here, they go ahead and put it back in a fraction form, so that puts it back on bottom. So you have the negative 1600 over x squared plus your 0.35. All right, finally, in this particular problem, we have a company that can sell X units of a product when the price, which is also what they're calling D of X, is 3 minus 0.002 times X dollars. And then they're telling me that the total production costs are going to be C of X equals 0.005 X squared plus 0.62X plus 250. They want us to find the marginal profit. So we know that means we're going to take a derivative of the profit, but we first need to find the profit. And when you're dealing with profit, it is always your revenue function minus your cost function. And so in this case, for my revenue function, I am going to have to take what they're giving me in terms of the price or the demand. So that is the $3 minus the 0.002x, and then multiply it by the quantity, which is x. So that's my revenue function. And then I have to subtract my cost function, which they gave me here. Put it in parentheses because all those terms have to be subtracted. So that's a 0.005 times x squared, and then plus a 0.62 times x, and then plus a 250. Okay, so let me do some simplifying here. We're going to distribute first. I'm just going to call that a 3x and not carry those decimals. And then I've got minus a 0.002 times x squared. And then I have a minus 0.005 times x squared. And then minus 0.62 times x, and then minus 250. So don't forget, you're distributing that negative there. All right, so if I now combine my like terms, let's put the x squareds up front. We have a 0.007 times x squared, and it is negative. And then we have a 3x minus a 0.62x, so that's actually going to leave me with a positive 2.38 times x. And then we have minus a 250. So this is my profit equation. So now I'm going to go ahead and write that up here since I'm out of room. So my profit equation is negative 0.007x squared plus 2.38x minus 250. So now if I take the derivative of that, I'm going to take this power of 2, pull it to the front and multiply. That'll leave me with a negative 0.014, and then decrease the power of x by 1. And then plus, take my power of 1, pull it to the front and multiply, so that becomes a 2.38. And again, when you decrease that power by 1, you just have x to the 0, which is 1. And then finally, the derivative of the constant is 0. So this is my final, what we call marginal profit function.